Welcome, everyone. I am extremely excited for our next session and our next speaker, Michael Leach. Michael Leach is the founder and CEO of iDialogue and is operating at the cutting edge of AI in Salesforce. He's developing and deploying Salesforce apps with innovative AI solutions, with history marked by pioneering efforts, including launching one of the first apps on Salesforce's App Exchange. Mike is one of the best examples of transformational leadership in the Salesforce ecosystem. His extensive tech background from the dot-com boom through cloud computing and now into generative AI helps him navigate and innovate. At iDialogue, Mike is working revolutionizing how SMBs leverage Salesforce. He's integrating AI to enhance efficiency and effectiveness. He's a seasoned speaker and Salesforce MVP, and Mike's contributions are highly respected for those leaning in to explore the future with AI in Salesforce. Everybody, please give a warm welcome to the stage, Mike Leach.
And thank you to everyone who's attending this session on retrieval augmented generation, or RAG, techniques for Salesforce, or basically building intelligent dialogue-based conversational AIs. First, I want to take a minute to really thank Mark and the people at Elements.cloud and GOTS. This is quite a production, and it's not just the effort that goes into this conference that's leading up to it. It's the emails, the websites, and he's just been sticking at this for years now. So thank you very much for everything you guys are doing behind the scenes. It's really easy for speakers like us to come in, thanks to the work that you're doing here. Okay, let's do a quick recap how we've arrived to this conversation around RAG. So before we had RAG, actually it was actually August 2023, the last GPT Dreaming. We were chatting with individual opportunity and case records. We were chatting with individual file records, uploading images, documents, and conversing and extracting information. The logical question that evolved from that was, can we chat with many records? Can we chat with an entire Salesforce org? Can we query an entire library and many files? And so the answer then was kind of a stay tuned. There's new technologies, there's larger memory on the way. And so RAG is this kind of this new technique. So in this presentation, we're going to talk about what is RAG, why is it needed, when to use it, some trade-offs when using retrieval augmentation versus inline context. We're going to get specifically into a few patterns, retrieving data specifically from Salesforce. We're going to address the security, some of the limits and the challenges with RAG. And we'll get into some real world use cases, some customer use cases. Careers in AI. I mean, the amazing thing is that this technology is here today. It's just left for us to build it. And Martin and other people have been showing kind of these slides, where we're at in the adoption curve and this trough of disillusionment. But, we're kind of going the upswing where people are seeing the real world examples, and guys like Mark are doing training. We're really at a point where we just need people to pick up the tools and learn them. So I'll talk about careers. And if there's time, definitely want to answer some questions and chat with some people. So thanks for Mark for the background. We're on the App Exchange. I'm the founder CEO of a company with an app called iDialogue on the App Exchange. In this presentation, just for some background, there's Salesforce, there's our app for conversational AI. We're using OpenAI and Azure for the large language models, embeddings, and completions. We're an Amazon partner, Amazon Web Services for many years. We started in document management, PDF, and we've had layers of OCR, optical character recognition, vector databases for a while. We use Amazon for that. And we're also using Midjourney and DALL-E. And I asked DALL-E to create an image of what is RAG. And the prompt here to the left, create an image of a visualization that supports RAG architecture. It actually did a pretty good job. I find with DALL-E, a lot of times I end up iterating and it's the second or third iteration, but this was actually a first attempt with a hasty prompt. So we have like two humanoid like entities conducting a dialogue of a sense. On the left-hand side, we have this inbound user request going through what the AI is depicting, I guess, as the vector database, transforming that into embeddings, which is kind of the natural language of AI. So pretty interesting photo. I've interspersed it. And I like being pretty transparent. I mean, the artifacts here, the misspellings, um, the symbolism, and that's where we're at with AI. And honestly, that's why we need prompt engineers and developers to do these iterations and kind of work through these imperfections that we get. It's like kind of crafting with clay. Uh, I've learned to kind of give a quick offering to the AI gods. Wednesday seems to be kind of a peak day for B2B IT in general, but OpenAI last week at this time on Wednesday was pretty much down due to what I think was a a denial of service kind of attack. So if at any time during this demo, there's bad gateways or timeouts, that's just kind of an artifact and could be operator error. In fact, when I do training, I will actually inject misspellings and try to break things just so I can show you my troubleshooting process. If you're using GPTs today on OpenAI, you're already using RAG, and it's becoming pretty pervasive kind of under the hood. So if you're creating a GPT and you're uploading a PDF for that PDF to represent the knowledge of your chatbot, then what's happening behind the scenes is that PDF gets uploaded, they run a bit of script that chunks it out, usually like one paragraph per chunk is a good starting point. Puts it into a vector database. It does some embeddings. And then when you're chatting at runtime, that becomes a type of action. So even with no actions defined on your chatbot, it is in real time trying to determine, hey, should I go to this PDF? And this other retrieval mechanism that's becoming, it's kind of pretty firm in the AI operating system for these actions. So that is a form of retrieval. These actions can go out to a vector database, so they could go out and check Shopify, and there's a number of that check the weather. There's a number of retrieval mechanisms available there. So within Salesforce, the benefit of OpenAI being open is that every time they publish a new feature, Azure receives the benefits of that, typically within a few days. Bing, our own products. So they are AI as a service, which means in Salesforce, we've just created our own abstraction. So instead of actions, we have AI skills. Instead of conversation starters, we refer to those as prompts. Our files, we're using related list of files for knowledge in Salesforce. And the kind of base settings is what we call an AI model. So I want to paint a picture kind of at the 10,000 foot view of AI as an operating system, because there's a lot of moving parts. It's taken OpenAI themselves about 8 years to get to this point. And if you look at the characteristics of an operating system, it's the interface between user and hardware, resource management, file IO, user interface, security, networking capabilities, instruction execution. So we just wouldn't build these individually. We've reached a point where we need an operating system. And if you go back several decades ago, we were at the same kind of inflection point where we had Microsoft Office, we had Mac OS and Linux, and we all like to toy and play with these LLMs at the lower level. These are kind of the CPUs of the operating system, but practically speaking, at the application level, if we're going to deliver value to the enterprise, we need to start understanding and adopting one, or it might be two or three operating systems. But these are all abstracted in everything we're building upon. So we think of kind of version one of this operating system when it came out. ChatGPT is barely even 2 years old. We had this really kind of vanilla GPT approach. And then in these slides, I'll kind of work through how we got to RAG. So RAG kind of fits in this middleware as a controller. And I'm going to use a full stack metaphor of a model view controller. And the view going forward is this chat GPT or conversational AI on the left-hand side. And we started with what was called a 4K token limit, about 4,000 tokens. That's about 3,000 words that you can fit within a stack frame for a conversation. So we had to be very selective in what we put in to the grounding prompt. If we're working with roughly 3,000 words, so we have a grounding prompt, the user message comes in, that gets sent to the kind of the middleware here where they're determining the intent of the user's question. There's some moderation. And then just those two pieces right there took them about 5 years to build. So the moderation, the fact that, ChatGPT at that point can turn around and just say, hey, regardless of your grounding prompt, this is just not something this operating system is going to process. And then that gets passed to a large language model in the back end. And we spent pretty much the bulk of the last GPT Dreaming focusing on LLM, so I won't get into that too deep. So, example of that today, if I were trying to build an enterprise app based on that vanilla kind of approach. So I'm on a case. I have several details on this case: phone number, customer, subject, description. And if I were to ask kind of a GPT vanilla model, hey, to summarize this case, it has no context, it has no grounding, it has no vector database to turn to. And it's just going to say, hey, yeah, I'm happy to help, tell me, provide the details for me. And so, you would type in or might have a text file and cut and paste and go back and forth. If I ask this to, let's say, troubleshoot this case, and again, it's just kind of giving me the vanilla response of, sure, provide me some details. So that quickly evolved to GPT 3.5. So let's focus on what's changed here. Let's take a look at, so now we're at a 16K token memory, and that's about 5,000 to 10,000 words we can fit into the memory of a chatbot. And when I talk about fit into memory, I don't mean that's really a hard cap. There's actually some dynamic truncation and compression and things that happen along the way, and even in these early models. But so we had this ability that we demonstrated in the last GPT Dreaming was a flow kind of intermediates and can pull in some Salesforce data and some files and put that into the grounding prompt. So by the time the user is asking a question, it has the luxury of some contextual enterprise data. And that's, again, going through intent and moderation. Also with 3.5 was the introduction of what they called tools at the time. It's actually gone through 2 or 3 name changes, but started out as their functions API. And they also introduced fine tunings with 3.5. So this was an ability, it's really an advanced feature that developers could upload a lot of, Martin was referring to FAQs in a previous, it's kind of like you're assembling a lot of conversational key value pairs, uploading it. And so without any contextual data or grounding prompt, those fine tunings in conjunction with the LLM would provide a response. So we had more tools to kind of play with. If I go back to our kind of our transactional model, so actually we're going to run a flow here when the chatbot initiates. So I'm asking this chatbot to summarize the case. It says, okay, yeah, here you go. I'm aware of all of these details. And this is where we got into, generating emails and responses. And there was a lot of low hanging, you could just type a few words based on just the transactional initialization alone. If I were to ask this bot to troubleshoot this case, it does not have FAQs, it does not have access to owner manuals, and so we're getting kind of a blended response here of it's taking what it knows about the case and it's forwarding that onto the LLM, and it's kind of coming back with a mixture of public information. But you could potentially call this hallucinating. It's not necessarily giving a wrong answer, but it's not giving the right answer. So, but it is progress. There's a lot we can do within a flow. So the flow that just ran there really just kind of quickly zipped through. It got the case, it described the description of the case, account, contact, if there were emails or case comments, that pulled those in. And because we've now shifted the development environment to flow-based and DML retrieval of records, you can really kind of fan out and pull in as much information as you want. Not shown on the screenshot are some text templates where we're actually giving the bot its mission and tone, and you are a helpful assistant kind of grounding. And additionally, more often we're doing multi-shot prompts, and we're helping the bot understand to anticipate, here's a series of questions that might be asked, like this car lot that published a chat bot with not a lot of grounding. Well, one of the fixes would be, people might ask you to compare your cars to Tesla, or people might ask you, hey, can you give me a 50% discount? So you just do a lot of multi-shot here in the flow, and you give it the desired response. Okay, so then our operating system has evolved to GPT-4 with RAG, and so this is starting to look a little bit more like a modern day enterprise architecture. The first thing you'll notice is our memory limit. We've gone from 4K to 16K, and then currently we're at 128 with GPT-4. That is about 50,000 to 75,000 words, which is, I think the average novel is about 70,000 to 120,000 words. So you can practically an entire book into the initialization of a GPT-4 stack today. And, we still have this flow capability where we're pulling contextual data in, but now we can pull even more data in from enterprise systems at grounding and initialization. So by the time the user initiates the dialogue, we're going through intent and moderation. The function router now has access to a new capability called a vector database. And this vector database has been initialized with really anything. It doesn't have to be text. It could, as we've seen with Sona and some of these new AIs and video, audio, vectorization simply is converting any data into a format that is a vector. And these vectors are optimized to be executed in inference models on GPUs. So I've thrown a lot of buzzwords out there, but the baseline is we've added a new database. It's kind of caching now the Salesforce data, the files, enterprise resourcing. And so this is the RAG. 1, 2, and 3 represents the RA and G. So this function now has the user data, and at runtime, it's determined, okay, go and fetch maybe 2 or 3 other pieces of text, add it on top of the conversation stack. The A here is augmentation, so we're augmenting the user request and passing it to the LLM. And the G here is generative, as we're returning that back to the user. So what that looks like here, and for tried to be clever in some of these AI models, I apologize, but we have the vanilla model, we have the transactional model, and then we have this multi-dimensional ice cubed kind of model that can reference vector databases. So this model here, as we've evolved through them, still has access to the case flow, but now I can say things like troubleshoot, resolve, and update this case. It's thinking about it. Okay, so it says I have found a relevant information in the FAQ. Gives us specific oils, temperature ranges. I have updated the suggested resolution based on this information. So yeah, let's verify that. If I edit this record, so I have this AI suggested resolution custom field, which was blank. If I edit this, so the AI is updated, it's extracted from the FAQ and updated this. So human in the loop, still doing some editing. I know it's winter. I might be able to say, the human can say, given we're in winter, use, and then there's some specific reference in there. So then I can go back into any sort of customer communication. In this case, I have a portal, document room. And by default, there was no resolution on the customer facing experience. If I refresh it, I should get this, here's recommended oil types. And well, actually, and we need to go back and troubleshoot this because, and this is why I said when I do these demos, I actually like these imperfections to show up because that's not exactly what I wanted. What the AI came back with was the right partial of this FAQ. And so I would have to do some more development on this to get the right resolution. But here's how I would troubleshoot it. So I'm going to open the dialog tab here. And we have a record here. And I'm going to open up a transcript for what just how we interacted with this ICE cube model. So you'll recall in our stack, kind of bottom up, we do some grounding, contextual data. A lot happens before we actually get to any of the AI interactions. So it initialized the model. It knew it had some tooling available so that it could call out to update case resolution. We gave it an action where it could call search case FAQ. And our system prompt, so we've baselined it with some grounding here, act as a helpful assistant. And again, people like Slalom consultants, other people can really kind of sit down with you and get these baseline groundings correct. The case flow here has extracted contextual data. So now in runtime, we actually know the actual account, we know the case, we know the details, case comment history. All of that transpires, and finally we get to the user request, which is summarize this case. And not too many tokens, fractions of a penny here. We get kind of the accounting of tokens, and it comes back. It did not have to invoke any skills or actions to reply to that user message. It assumed it had enough in the baseline that it could answer that question. So the user comes back and asks another question, troubleshoot, resolve, and update this case. Well, not a question or instruction, rather. And we see here that it decided to invoke two skills in serially in sequence. So first it created a kind of a query strategy. It's going to call search case FAQ, pass in a query, maintenance guidelines. So that's at a high level. This went into the vector database and it found in the FAQ the top 2 or 3 paragraphs it thought were most relevant to that question. Then it invoked update case resolution with arguments, field name, suggested resolution, recommended checking the user manual. So that's quite not what I wanted. And I would probably go back, and there's actually prompts where you can suggest that only do one action at a time, or only do them in these sequences, or ask the user before you update the record. So, if I were to do that again really quickly, just kind of learning from this. So let's go ahead and reinitialize. And start a new dialogue, and I'll just ask it simply to troubleshoot and suggest a resolution. So that's going back to the vector database, and then we get, okay, what looks good, and then I could say update record. We'll see what it does. Hopefully we get the details of the specific oil types. Okay, so yeah, so now we're getting, this happens a lot of times with this linear progression of these models, is that it likes to interpret these things as a series of prompts, and it's always predicting the next token based on what happened prior. So we gave it, what happened prior here is we gave it a pretty strong answer out of the vector database, and then we gave it a very literal instruction to do the update. So that was more the outcome I expected. So RAG, if we just kind of break down what we saw in the transcript there, that when a skill gets invoked and an action gets invoked, that's the retrieval mechanism. It's going to the vector database with a query. Yeah, kind of in between the retrieval and augmentation, it's actually converting that user prompt to an embedding. And there is a latency involved in doing that conversion that you have to be aware of. It's augmenting the response from the vector database with the top N results. N in this case, I think, is 2 or 3, and it's generating the outcome. So let's take a look at this model. If I look at, so we established kind of the baseline of its temperature, very low temperature in these types of models. We don't really want it to be too creative in a vector database. We actually want the most literal interpretation of the user input whenever possible. We're calling a flow on initialization to ground it. And over here, we have a couple skills. So here's where we gave it the capability to branch out and search a knowledge base and to update the case resolution. So if I look at our AI skill, so on the right-hand side here, we have a bunch of pre-canned, what we call primitive functions. We gave it the semantic search skill. And we gave it, you want to give it a function name that's closer to what the user is actually asking for. So under the covers, this is just generically calling the semantic search base class, so to speak, but the abstracted function name that we're providing to the AI is search the case FAQ. And the AI actually uses this skill description and input description as part of its tokenization during the initialization of the bot. And these do count towards the tokens, the descriptions on the inbound tokens. And finally, we've told it your knowledge source is attached files. Your search source is retrieval augmented. 2 options there being we can kind of slam all this into the inline prompt context, and we start risking that 128K token cap, or we can do retrieval augmented, which is we're putting nothing into the token inputs at initialization. And we're telling it to return the top 2 responses from the vector database and insert that into the flow. So it's deriving, so I just uploaded a file here as a related file. It's a text file and FAQ. And if I look at the oil specific FAQ, then yeah, that looks right. So the previous bots, more of the vanilla and the transactional, were hallucinating. They didn't really have the benefit of a file to give it a literal answer. And then we've evolved this model to have the intelligence to know to go to a specific file. And because this is a Salesforce file, I have the luxury of version control. I can upload multiple versions of this. When we talk about careers and jobs, the architect have just kind of done their job at this point. They can get out of the way, but the ongoing maintenance of this model requires ongoing editing, testing of these FAQs, uploading new versions of it. So it's kind of like a new skill, like you're working with Excel or any other IT productivity tool. Okay, a final thought on the AI operating system of the future, where this is going. You can quickly see the extrapolation, the patterns here. We've gone from 4K to 16K to 128K, and with Claude, they're already in production at the 200K token. So we can start asking ourselves the question of what happens when, not if we hit the 1 million token context, but when and what will we do with that? What are the implications of that? And I saw an interesting article today that kind of got to they made a point that maybe 10 million tokens is a theoretical, like we can't even rationalize that many problems where we would put that much data into a memory buffer. I don't know. I'm sure someone will load every genome of every species into that kind of buffer. The thing to keep in mind, however, is when you load that much data into the conversational stack, that entire payload, that millions of words potentially, goes through the same process there are there's intent, there's moderation, there's function routing, and there are charges, so you pay for all those tokens. If I upload 500,000 words into a bot, but all I wanted to do was get the oil out of it, those 2 paragraphs, well, I got charged $5 or whatever for that transaction to load it all into memory. So an architect at all times has to be keeping things in balance of how much you want into the context, how much is always in the grounding, how much is more dynamic. So what else is going to happen in future state in the lower right-hand corner? We now have past chat and conversation history included in the vector database. In fact, another presenter, I think, made mention to this. OpenAI just announced a pilot where you could opt into this feature, which was they call it long memory. And basically what they're doing is they're storing all your past conversations in a vector database. And when you ask it a question, if it determines the intent of your question is a recall related question, it will go into the vector database, pull the top end relevant chat history fragments out, and augment the chat with that. So we're potentially starting to reach a state where someone born in the year 2030 just has this in perpetuity infinite dialogue with a chat bot without ever clicking on new conversation. It just knows every homework assignment, everything you ever bought on Shopify or Amazon, and it knows your entire history. And maybe that's a new Apple feature. I don't know, but this would be how we get to sci-fi level personalization with chatbots. So I've talked about some of the trade-offs, putting all the data into inline context. Well, for one, it's just path of least resistance. We can be pretty lazy and we're just pulling data, put it in the chatbot, and then let the chatbot figure out, what was relevant in that payload for it to answer it. It's really ideal for loading many files. It's completely transforming the legal space, the ability to upload into memory every contract. And you really don't want this semantic vector pull out partial. You want the entire contract or many contracts and agreements loaded within memory. So there are use cases going forward that will be totally optimized for inline context. It's a little bit slower runtime. Wirth's law is kind of coming into effect, which basically says, as NVIDIA and the CPU or GPU manufacturers are giving us more and more powerful hardware and compute, software people are just like dumping more and more stuff on top of it and utilizing it. So and it obviously costs a lot more when you put a lot of inline content into a chatbot. So with retrieval augmented, the trade-offs there, it's a little bit extra development effort. You have to define the skills. we dug into one of these skills, another one being the update case resolution. So, I went in and chose, for example, the update fields primitive, and I gave it some grounding of when to call this function. And I probably had to iterate for an hour to get this just right to the way I liked it. And this is very simplistic. It's only updating one field. You can train it to update any field or multiple fields. But as a trade-off, there's a time trade-off is the point I'm making is this is a new career skill. This is an AI developer is basically doing this where it's, yes, the prompt is relevant and you have to be very aware of prompts and prompt engineering, but you also have to contextually understand the balance of when you're executing these prompts and delegating them to vector database. It does require a vector database is one of the trade-offs, but it's far, far cheaper because, like I said, you're not loading as much information into the bot. Okay, so this function router, we've been going to a vector database, and traditionally people interpret RAG as being a vector only type of pattern when technically anytime you augment a chat with any sort of retrieval method, it's technically a RAG pattern. So we can ask AI to generate SQL, SOQL, SOQL, tomato. Somebody should probably do a poll on the correct pronunciation of SOQL. SOSL. AI is very, very proficient at generating anything structured, query languages particularly. And like 99% of the time, it will do it precisely if it's been grounded correctly. I'll open up a bot here and we'll play with one that has no grounding, and it's fairly accurate. We can retrieve data from flows. There are many cases where we're not going to entirely delegate to AI to like create an invoice or do certain go down the pricing waterfall for discounts. And so we have a lot of pre-built infrastructure and Apex classes and flows. But we can still have a conversation with existing middleware and Apex and flows. But we want to use AI to help the user to determine which artifact we're going to call and what are the inputs to it. Then on the vector database side, largely we're seeing, unstructured would be files. That's our kind of number one use case in our AppExchange product, but also structured data and comprehensive data. And you would use comprehensive pattern, and let's say an account-based AI, where you want to chat with an AI that is aware of an account's entire history, their cases, their opportunities, the contacts, the tasks, the emails. And it might be cost prohibitive to go out and query all those records at runtime. So what you do is you build a comprehensive snapshot of an account periodically. It's kind of like the new data warehouse. You determine you want to do this nightly or hourly or only when a record changes. But we build a lot of these series of comprehensive snapshots. We put them in a vector space, and then it just takes the conversational level to it's 10x. I mean, you're talking with a bot that is not only is it aware of everything about an account, but it's aware of it on 5,000 dimensions. And there are patterns inside there that humans honestly just will never see. And it will give you these serendipitous kind of answers that will really make you think. So that's kind of the next generation where this is going. I think I have a basic bot here. Yeah, so here's one. I'm going to start a new one. This one only has two skills. It can describe metadata and it can generate SOQL queries. Or sorry, I want to describe the account object. And I've been talking a minute here, so this cache is kind of cold. So this is a little bit, anytime you go to the metadata in real time with a user, it can be expensive. There are some tricks when you initialize a bot where you could say, you are aware of every standard and custom field on these 3 objects, and and you can cache that metadata. Um, but at this point, this bot is basically aware of what is an account in the field. So I can ask it questions like, which accounts are in the energy industry. And it's thinking about it, and it's going through that intent, moderation, function router. It's going through that process. It determined it needed to call a function to generate a query to do this. And let's go ahead and I always have 2 tabs open. As a developer, you want to have your transcript open and periodically refresh, just kind of go back and forth between the 2 tabs. So this initialized has a couple actions. It can call describe object and it can call query records. And the first thing I had to do was describe the account object, got tons of data. And so I'm already at a little over 5,000 tokens just on that level of initialization. Then I asked it which accounts are in the energy industry. It determined to call the query records with select ID name industry from account where industry equals energy. And we got back a few results. Now, because this is AI and this is vectorized and semantic, I don't actually have to know, as long as the AI knows the schema, the user doesn't have to know the schema. I mean, I can kind of get lazy here. I can say, which accounts are in the energy industry, include columns for type, rating, and I'm just going to do BLNG. That's really just a bad spelling of billing state. And so it's going to do the best it can to kind of match my intent to the schema. And it did correctly come up with billing state. And if I refresh the transcript here, I mean, I could play with this all day. It can do inner joins. It can give it more schema. You can pre-can some suggested conversation starters. You really, in a production environment, you want to do some multi-shot prompts and actually say, hey, the user will ask this, and this is the way I would structure the query. Yeah, and just the last kind of, it doesn't understand, I haven't initialized it with the contact schema. What I'm going to do is ask it for which contacts belong to accounts in the energy industry, include, I can spell here, columns for email and phone. And, to the degree it's influenced by a Salesforce public article on the schema of contacts. So it correctly selected some accounts. And if we want to verify these actually are in the energy industry, let's go back to our transcript. Yeah, so we got select name, account name, email, phone from contact, where account industry equals energy. So anyway, I could go on and on with these patterns. There's queries, there's flows, there's Apex, and what I would call more the transactional patterns. So let's shift gears with the time we have left. So semantic search. So this was kind of, at least with our customers, a lot of people came back with our file GPT demos. Hey, yeah, Mike, that's great. I can chat with one file or I can run flows, but I have thousands of documents. I have years of owners' manuals, operating manuals. And so in the aircraft industry we're seeing some early adoption, uploading a lot of technical publications, manuals, service bulletins into libraries. And I have an aircraft record here. We've added a tab for AI assistants. Each one of these assistants can have one or two skills. They could have, and I'll get into like a theoretical limit of the number of skills. I mean, I'd say seven's kind of a magic number, but it really comes down to the semantic separation of those functions. So this just did a search across all the documents looking, let's just say this aircraft has come in for servicing, and the maintenance repair overhaul operator wants to make sure that they're taking a safety first approach. Are there any recalls? Are there any service bulletins? And so we got back a couple files here. And these are huge documents. These are some of these are about 300 pages. And yeah, that's going to take a minute to load. And you would not want to put a 342 page document into your chatbot on initialization. But what we would do is just put all of this into diagrams and all, put it into a vector database, and at runtime, let the chatbot determine which of these documents contains a paragraph or two that is most relevant to the user's intent. Another thing I like to do is that keep in mind that everything I've been doing is in English, but it's really just storing this information as a lot of numbers. So I like to do this demo where we're, let's do the same search, but let's do it in another language. And so it's still going through its controller layer of the intent. It's doing some translation, it's doing some search. Basically comes back with the same two documents, but a completely different language, completely different query. But yeah, let's go into the dialogue to verify that. It's not, translation's not always 100%. And again, part of the role of an AI developer is you need to be always validating what the bot did. So we gave it one skill, which is search publications. That's pointing at what's called a vector space. And a vector space is also on the AI skill you set up. It basically looks like a file system path. We gave it a kind of a /files/Cirrus technical pubs folder that is synchronizing with the library. So there was a prompt, the skill got invoked. Query was safety, emergencies, risk management. Out of all those PDFs and documents, it thought that these, looks like 4 or 5 paragraphs are relevant. Then we did the same query in Japanese, and it determined safety, emergencies, risk management. And so that's not 100% the same as the previous one. Well, yeah, it actually is. It just inserted a comma into each one. Curious. Okay. I'm learning all the time. But like I said, I could do this all day. It's so much fun once you get this set up, because it's a new job, AI architect, AI developer, prompt engineer. This is just what you're doing all day. And playing with this stuff. And yeah, go to Mark's course. He teaches some of this stuff. Sales enablement. So this is I recommend this as kind of the first project for a Salesforce admin. You're launching features all the time. You're adding a new custom field. You're updating the page layout. And what you could do today is send everyone in your Salesforce an email, say, hey, by the way, we just launched a new version. Here's a screenshot of the page layout. Click here for a video. With AI, you can actually just inline, if you were to launch, for example, some new quoting capabilities, and give the sales rep some conversation starters so they know some capabilities of the model. In this case, I'm asking, how do I create a quote? And it's saying, hey, in the upper right-hand corner, There should be a quote room, click on generate documents, things like that. Or the user just might throw kind of a curveball at them, like, how can I be notified when a customer views my quote? And it's in a vector database. There's these FAQs. The systems implementer and admin has already pre-built this article. Finds the best match. It says, oh, okay, you want to go over to the activities tab, and that'll give you an idea, if the customer has actually opened your email or opened the quote. So you manage this through a custom object, actually any object. Again, I keep going back to Martin's methodology of establishing the FAQs, because bottom up, that's really how to guarantee more success. But it's just simply a record with a rich text editor on it, and you can edit it, put some text. You can give it some hints. I've added a custom field here called metadata keywords. How do I generate a quote? How do I create a document quote room? This will kind of seed the vector database so the AI can anticipate certain types of questions. But when it does that matching on the vector database, these will come up as the highest probability matches, and that's where you get the best results. So I've been opening that dialogue tab a lot. From a development perspective, but also in retrospect, as you start scaling and you have a dozen chats a day, 1,000 chats a day into the millions, pretty soon you're going to accumulate a database of just the dialogues. And they're just large text files. You can actually process the output of these chat dialogues like you would any other text document, use AI to audit AI. So that's a little bit of kind of state of the art. I imagine those tools will evolve. I mean, we have our records and databases are all public, and well, they're not public, but I mean, they're in a managed package. They're available privately to a developer, and you can write your own retrospective analysis. Like, um, is my AI in alignment with what I expected and you could take a sample of the past 100 chats, for example. So RAG security, obviously, as every technology has come around, it's always created the job of security, and that's no different with AI. I would say it's no more, no less. I mean, you just flat out, security is a job that you have to do. You have a vector database, you have to do your normal vendor selection. The more data you have in there, the more you're leveraging the multidimensionality. But with a vector database, it is not text. There's not really the equivalent of like field level security. You can write queries and put certain information into a vector space. But in this customer chatbot, if this customer had tried to go fishing, I mean, they could ask things like, what gas type should they use? But if they start getting in the prompts like, who am I? And trying to fish out what the bot might have cached in the vector or the record about this user, then that becomes a path to getting information out. And so our job really as security professionals is the best way you can think about this is how you would partition a customer portal or a community. You have internal and external, and when you get up to the drawing board, when you're talking about security, I would always start with those two. You always have two vector spaces. So internally, I'm chatting with these accounts and I'm running queries, and I can do inner joins as more of a business analyst role. And I really want 100% access to this data, or whatever can be granted to an internal analyst role. But externally, the customers, they need first name, last name, email, and maybe that's it. You want to have this separate vector space that is limited to what you want the customers to see. And at a more granular level, like that case room was actually this is a good example of the role of an AI architect is to balance a vector versus inline context. We would want the customer data transactionally in the inline context. But if that customer goes to search 1,000 owner manual and PDFs, that's a good default use case for put all that in the vector database. And what does a vector look like? It's really just a lot of numbers. You cannot, by the way, you cannot reverse engineer a vector and get the text back out. I mean, I'm saying that I'm sure some cray computer and someone with a PhD will figure out some way, much like RSA encryption. But generally speaking, it's one way. By the time you go from symbolic representation to vectors, it's just a bunch of numbers. And then we're taking the user's request and we're also turning it into an array of numbers. And then side by side, there's cosine similarity, other types of matching that are going on, but that's basically what a vector looks like. Running short on time, I'm just going to zip through some slides, some customer use cases. I think in a future GPT Dream, we'll actually just start bringing some customers in to talk about these. I showed aviation a bit, healthcare, tech, nonprofits. We have a partnership with a great company, Aviate Now, on the App Exchange that does Part 135 solutions, and they're using our library as more of an OEM embedding model. So they have flight agents, reservation management, a lot of documents. I'm really liking the MRO space, maintenance, repair, and overhaul, just from a safety perspective. We have clients that are taking pictures of a cockpit, and AI is figuring out, oh, that's a Garmin, that's a this is the serial number, and then we're bringing that in and cataloging it. Customer-facing chatbots, kind of the future of CPQ. I could do a whole hour on this, but we have this event-based model that every time the customer clicks on the workspace, it raises an event, and the GPT bot says, oh, that's a great choice. Can I suggest some other follow-up things? And back and forth, you can actually configure a car or a tractor through the chatbot, raises an event and repaints the workspace. Again, going back to this recurring theme of safety, I'm really impressed with the potential. One of our clients is utilizing prescriptions, drug interactions. There's just a tremendous wealth of information out there in the healthcare industry. And it's you're never going to remove human in the loop when you're dealing with a lot of healthcare. But just to have that 24/7 backstop, that filter that is checking for drug interactions and is double checking your work, it's great solution. Nonprofits, donor management, some great use cases out there, both internal and external. Internally, we have some volunteer onboarding AIs that we've sat down with the CEO of the nonprofit, and understood their mission and what they want every volunteer to understand, and then people in the field are kind of empowered with what that mission wants. Donor summarization, account summaries. So, we're actually in kind of end of year donation lever season now. Really the only one I want to highlight as a limit is DevOps. We want to get into this proper, like, develop and do in a sandbox, promote to production. And so we're working on that. We can serialize everything and move it around, but a current limit is around DevOps. And again, looking to partner with some people to redefine DevOps. Careers, I've been kind of mentioning as we go. I think AI is one of these areas that is going to impact 100% of the workforce, in the sense that if you have a mobile phone and what you do is a job or a desktop, then AI will be an option to you, much like Excel or a word processor or any other tool. It's just something that's going to be there on demand. It's AI as a service. It's always on. It's in the cloud. And these new roles, we need people doing this today. We need business analysts. We need AI modelers and skill developers. We need prompt engineers, flow developers, AI architects, kind of handling the balance of all these things. And we're ready to run with it. AI chip revenue alone is going to be 80 billion over the next 5 years. And even at my most conservative estimate, kind of the halo of jobs is about 10x of that. But practically speaking, as we roll out all these, NVIDIA is now, I think, the number 3 largest company in the world by valuation. But yeah, huge impact in software and pro services to start rolling this out.